Perform an activity to investigate the relationship between potential difference across parallel combination of resistors and the potential difference across each individual registers. Huh. What is the question talking about? See, this entirety is your parallel connection of resistors, right, between node A and B. Now, if I happen to give a supply of V volt or V dash volt, okay, or maybe 10 volt, let me take a value. They're asking us, if we provide 10 volt over here, what is the voltage across each resistance? What is the relationship between this 10 volt and voltage across each resistance? The relationship is that they also will be of 10 volt. Okay, the voltage will be same. Yes, the current might be different, but the voltage will be same. Voltage across each of these resistors, right? Between this ends, whatever the combination of resistors are there, they'll have the same voltage. Okay, the reason is quite simple. See, if I happen to pick an object from point G to A of height h, whatever way I take, a direct way, path 1, going straight up, left, up, right, up, or zigzag movement, path 2. It doesn't matter. Point is the height, right? Whatever it is, it will get the same pull. Whatever the path may be, the pull will be the same, right? In between, see, there might be many connections, but the pull is the same. From A to B, voltage is nothing but the pull, the energy or the work that will be done on the electrons. Is it not? Voltage is how much work is done on 1 coulomb of charge. So whatever the number of charges are there, it will have the same effect, right? Yes, the path they take will be different, and so the flow will be different. You know, there might be little flow in this space, there might be a lot of flow in this space because there is resistance is less. So such variations might be there, but the amount of pull will be the same. In the same way, how we lifted an object, if you pick a charge from one end, point G, and place it at point A, doesn't matter what the path we take. The amount of energy, right, will be the same from point A to G. Lifting it or dragging it or whatever you guys want to call it. Okay. So now we'll verify this experimentally. So here I have 3 resistors connected in parallel. It's not visible. Let me make it visible. Right. We have, see, 1, 2, 3 resistors. I can see their connection is over here, here, here. Same line connected to the same source of voltage. And here it is over here, here, here. Connected to, this is actually negative and this is positive. Okay, I connected ulta by mistake, and yeah. So your job is to, I'll be testing the voltage across each individually. So 1, 2, 3 across the 3 resistors. Individually I'll be checking, and you'll be having a look over the reading over here. And the maximum voltage, actually the voltage is around 5ish. So the maximum voltage that you can measure is 20. That's what I've set over here. So we'll be getting a reading in volt. So that will be your job, right? So we have 3 resistors, and you will need to measure the voltage. I would have measured the voltage. Your job is to make a note of it. Okay, so please watch the video. So what did you guys see? All of them was around 5 point, right, 3 odd, is it not? 5.3 something. Let me have a look. Actually, I forgot. Just a second. 5.34, right, in volts across the resistance 1. 5.34 against R2 and 5.34 against R3. So the combination of all of it, that is the main supply, right? Let it be R1, R2 and R3 itself. So that main supply is from this adapter. As you can see, it is 5.25, plus or minus something will be there in everything. So you can clearly see it was 5.2 is what it's showing, but yeah, it's applying around 5.3 for different reasons. So thing is, our experiment and observation was successful, and the concept is true. That is, the voltage across individual resistor or combination of it will be equal to what is the voltage across the node that is connecting all the parallel resistors, right? It's quite simple concept. So in parallel, you have the voltage to be constant across. So quite simple procedure, and I forgot to have the circuit only. So apparatus circuit I have forgotten. I'll show you guys that procedure. Make connection as per the circuit, plug in and note down the voltage across individual resistor. Observation and conclusion. So circuit is the same, right? It's not different. This is the circuit. Here we will be supplying with a source of voltage. Let me do that. So your circuit will look like this. The sequence is not correct, but yeah, you guys are well versed with the sequence by now, I guess. So I'm going to connect it to a voltage source, and it should have a key as well. So key and a voltage source. So this is V, that's a key, and these are your three resistors. Current will flow this end. This is positive, negative, positive, negative, positive, negative. That has to be mentioned. I forgot to mention that. Right, and yeah, that's your circuit diagram. So basically, this is your answer. Okay, so please have a look at your writing, at your running notes. If you want to make a note of something, please do so now.